And we're live. Welcome, everybody. Let's see who we've got here. Looks like we're live on all the platforms. We'll just wait for a few minutes for people to start joining. Wait for another couple of minutes and we'll kick things off. Okay, welcome everybody to the first ever Fix Bugs 20 times faster from zero to incident superhero. First of all, you need to sign up to GitHub, sign up to Replit, and then sign up to Dynatrace. I've done all of those three things, so now I'm going to walk you through the workshop. So we sign into Replit and go to this template, and we click on Remix Template, click on Use Template, and then it brings us into this main screen, which is the main screen of the app, which I've got running here. Okay. And then we're going to click Run to run the app. We need to wait a few seconds for the server to start up, and it'll auto open a browser with this tab. I'm actually going to just paste this link in the chat. Also going to paste it into the LinkedIn. Great. Doesn't work. Okay. So the next thing we're going to do is we should be seeing this upload pattern screen, which we've got here. And we're all set up. So this is a cross-stitch pattern app. Pardon me. I made it for my partner who runs an Etsy shop. And it takes an FCJSON file, which is a pattern file from a bit of software called FlossCross. This is FlossCross. And then it renders images from those. So we've got this web view open. We're going to download this Mona Lisa FCJSON below. So if I click that, it appears in my downloads here. It's called 7 just because I've done this a few times before. We're going to upload this. We're going to press upload. We're going to update pattern. And this will generate an image after a few seconds of the Mona Lisa. So this is using image magic in the background. It's ingesting an FCJSON. It's rendering the FCJSON as an image, and then it pops up here. Make sense? Cool. Gone through these 3 things. And now let's look at the defect. This is how it's going wrong. We go to upload pattern. And now we're going to try and upload this puffins pattern. These FCJSONs, I should say, are FlossCross JSONs. So it's just really JSON, but it's in a specific FlossCross format. And if we upload this pattern, click through the next screen, this will just keep spinning and spinning and nothing will happen, which is incredibly frustrating for the user. And this is not right. Yeah, there we go. I updated the docs here. So we want to show the stack trace for this. So let's go to the, let's go here. We'll follow the steps. We need to click on the magnifying glass. Close that tab because I'm getting confused. Click on the magnifying glass here, type shell. This will open up as a console. And then we can run bin errors. And as you can see, we've got 1 error sat there in the queue. This software is a bit of software called Solid Errors from a guy called Stephen Markheim. Thank you very much, Stephen. This is Stephen. He's a key member of the Ruby community, and this is a bit of software called Solid Errors, database-backed app internal exception tracker. It's nice and simple, and it gets us off the ground very quickly. So thank you again, Stephen. So we're going to open up this error and see the stack trace. Okay. So it's failing on this line within MiniMagick. Fine. And within our application code, there is this models pattern.rb in add border to preview. So that's kind of interesting. And it's executing a job. It's calling add border to preview. And then it's failing on this line here, line 291, where it says MiniMagick convert. But it's not clear which of the lines of this block. Well, first of all, it doesn't show the whole block. Second of all, it's not clear which line in the block is erroring. And thirdly, what's the error message? This is the error message. I won't even bother to read it out. Magic must specify image size. Okay. So why is the app crashing? Well, I don't know about you, but I have absolutely no idea why the app is crashing. Couldn't even begin to tell you. It's just too obscure. It's too abstract. I wouldn't have a clue. So the code is too complex, and the stack trace is not detailed enough. So we need to move on to more sophisticated techniques. Pardon me. So here are the 5 steps to observable software that I've developed. The question you want answered: decide which data to collect, build the instrumentation, use the graphs, and then improve. It's a little cycle. So first of all, the first step to do is decide what question you want to ask. And that's comprised of kind of 3 stages. Number 1 is form which hypotheses, in other words, guesses. What guesses are there as to why this might be going wrong? And then we need to rank those guesses by likelihood. Number 1, the pattern is too small or big. Number 2, it's the incorrect image format. And number 3, image magic is installed incorrectly. So these are just my kind of guesses, and I've ranked them. And given that we've got this error message saying must specify image size, that's kind of why I've put this at number 1, because it could be pattern is too small or too big. Okay. Next one. The next part is we've got our hypothesis, our most likely hypothesis. Now we need a question. A question I'm going to ask is, do the errors only happen on just one size of image? Nobody's watching, so I'm guessing there aren't any comments or any questions. At least I can't see who's watching. So, okay. We need to decide which data to collect. And we have these 4 ways of defining which data to collect. The 4 dimensions, really. The first one is what event was called. Second one is what to filter by, then what to group by, and then what attributes to show. And in SQL, this is what it would look like. Right. So, pardon me, we need to gather the width and the height and the error so that we can see what sizes happen at which errors. So for the ones that are errors, what's the width and height? Ones that are not errors, the times when it's passing, show the width and height of the pattern. And then the next step is that we're going to build some instrumentation. So just a quick note, we're using a bit of software called Dynatrace. I am very shortly going to start working at Dynatrace, but it can apply for all the observability tools too. So we're going to press stop at the top of the page. So we'll stop the server. We want to open up the console. So we're going to click, we've actually got a console open right now, but if we didn't have one, we could just type shell, same as this really, it's kind of the same thing. And we will run this command to install these gems. This semantic logger means it's going to be logging in a structured form. It gives us structured logging format capabilities within Rails. Rails does not have this out of the box. So that's done its job. Git diff, and we can see it's added those to the gem file, and it's also added them to the gem file.log. So that looks good. I'm going to create an OpenTelemetry formatter. Now, OpenTelemetry is this great bit of, it's a set of standards basically that the CNCF have created, and it's growing like wildfire. because observability traditionally has not had any real standards or conventions to it. So we're going to build in those standards and conventions from day one. And this, you'll get a little taste of what OpenTelemetry looks like. Okay, so we're going to open up that folder. We'll find the lib folder and we'll add a file in the lib folder. Add file, and we can say flat JSON formatter. .json. So .rb, I beg your pardon. Okay, we're going to take this code, we're going to copy it in flat JSON formatter. Don't need to save it, you can just close that window and you're all good. And then we're going to create an appender. So what's the difference between a formatter and an appender, you might ask? Well, an appender is something, is a little bit of code that details out where to send the logs. You can have multiple appenders. You can have appenders for any of the major error tracking bits of software, any loggers. You can send it to string IO, so you can have like a file that it logs to. You can log it to memory. You can log it to an HTTP request. So Semantic Logger comes with a whole bunch of these appenders. And then you can tell the appender, use this formatter to restructure the log before you send it to the destination. So we're going to create a log appender, and in this folder path, config initializes semantic logger.rb, config initializes semantic logger.rb. We're going to paste this code. Cool. Yeah, so this will use our flat JSON formatter, which means it's going to format it in OpenTelemetry. It's a bit of a rubbish name, to be honest. Probably should be OTel log formatter or something. And if we just open that flat JSON formatter again, you'll see a little bit about what it does. It always hard-code service name is mini cross-stitching. That's kind of the name of the service, which is the same as the name of the app in our case, because it's not a microservice. And it fetches all of these kind of details from the log and then maps it into these namespaces, essentially. And these are all in the OpenTelemetry semantic conventions. We don't want log semantic conventions, funnily enough. You want HTTP resource, I believe it is. Yeah, and then HTTP semantic conventions for spans, I believe. Yeah, so all of these things are standard names for different bits of the request. Pop that in the chat for everybody. Okay. Let's continue. The next thing we need to do is set up Dynatrace secrets. So I've got my brand new account here, Dynatrace. If we go into logs, it's telling us there's no setup yet. So if we click add logs, we want the log ingestion API. Okay, I'm going to click next. This is all in the docs here. Add logs, next. Press generate to generate a token. And then press the copy button to put it on the clipboard. And then we want to add those Dynatrace secrets to Replit. So we're going to go back to Replit, query, secrets. Okay. We're going to then click on new secret and enter the API token here. Okay, I hope this isn't going to show it. It is. Oh well, I'll change it the moment I get off this stream. Thanks, Replit. And then we're going to add a new secret, a second one. And this will be the Dynatrace app ID. For this one, you need to go to this little bit here before apps.dynatrace.com. This is a unique app ID for your Dynatrace account. I'm going to paste that in there, add that secret. And we're going to click run at the top of the screen again. So this is currently running the server. The server should now, in theory at least, be sending logs to Dynatrace formatted with this new structure. So we're going to check for those logs in Dynatrace. It usually takes a couple of minutes, maybe 30 seconds for them to come through. Okay, I'm going to start doing some stuff here. I'll do some Mona Lisa. Let's see. Normally takes maybe between 30 seconds and 2 minutes. Here we go. Here are the logs. So we are done. The next step, yeah, we've got it, all the logs showing up in Dynatrace now. So we can click Run Query. Here we are, lots of lovely logs. The next thing we need to do is simulate lots of different people uploading lots of different patterns into the app. Okay. It is it's kind of difficult to simulate this accurately, but I've not completely gone wild here. I've just created a very, very basic script called bin hammer, which means it's just going to hammer the server with loads of requests. I've reduced the requests a little bit since this documentation was written, so that means it's not going to take quite as long to churn through all of these different combinations. And all this is doing, pardon me, is just uploading a whole load of different colors, sizes of patterns. And this would be simulating users actually using your app and uploading their patterns and just using the app as simulated usage. Now, of course, in a real life situation, you wouldn't have to do this. This would just be your production system and all this would be carrying on regardless. So once it's finished, we need to wait a couple of minutes. Then we're going to go back into Dynatrace. This is the use. So just to kind of recap where we are, we've gone through what question we're trying to ask or answer. And the question we're trying to answer is, are there certain sizes at which errors happen versus other sizes where they do not? Cool. So that is the question we're trying to discover, the question we're trying to answer. And then we decided which data to collect. We wanted to collect the width, the height, and the errors. And we're going to come on to that in a little bit. We build. The next step is build. Now we've just built just enough instrumentation to send the logs somewhere and to structure them. And we're sending them to Dynatrace, of course. And now we're going to use these logs, and we're going to see what problems we have. Are we going to get the data that we want? Are we going to, let's just have something to use and try and use it to solve our problem. And so I'm going to run query again, and with any luck, eventually we should see some errors in here. We're not seeing that so far, which is a little bit worrying. By now we absolutely should have seen some errors. This may be where I have to pause the live stream and figure out what's gone wrong. All of those have succeeded. That's not great. Bin errors. Right, well, they haven't succeeded. There's several of them that have crashed here 2 minutes ago. But for some reason, we are not getting any errors in Dynatrace. We are now. Okay, so it does take a little while to come through. And so you can see here we've got a tiny little sliver of errors there. So we hover over the error and we're going to see 3 dots. And this is where we're going to narrow down into just the errors so we can see quite what's going wrong. So we're going to click here, run query, and this will show us only the errors. These are only the things that are going wrong. So there's 3 patterns erroring. Okay. Let's click on an error and try and figure out the root cause of this error. Okay, so we've got the same error that we saw in solid errors over here. Magic must specify image size. And then we've got another stack trace that's helpfully cut short. Patter. So that's not brilliant. We do. Sorry, my apologies. We do have the full stack trace. But even when we do have the full stack trace, it's just what we had before, really, isn't it? Except with no previews, no code previews. So let's scroll down, see if anything else is interesting. HTTP host, don't see how that would help us to diagnose it. An origin, I don't know what that is. This is the file name or something. Not too bothered about that. Couldn't care less what line it's on and which thread. So this is what I see teams try to deal with all the time. This is what I would charitably describe as a dead end. And yet teams seem to look down here and then they go over here and they go down here and engineers go back here and then click up and back to errors and then they'll click into another one and they'll look down here and could it be something to do with active error callbacks? I'm not really sure, but it could be this. I'm not sure. And I've seen engineers waste a lot of time just trying to read tea leaves, trying to read very minimal amounts of data, trying to just guess what's going on. Well, this is a complete waste of time. We don't have enough data. I wish I could, I don't say this enough. I wish I could emphasize this. You cannot debug an issue if you don't have enough data. It's impossible. You'll be here until you die. So this is a common anti-pattern in teams. And observability is not really about gathering data either. Observability is about answering interesting questions. And so we want to add just enough data to allow us to ask and answer these, in quotes, interesting questions. So yeah, we don't have enough data, so we need to gather more data. So just, as a reminder, we want the pattern with pattern height and error. And we're also missing this event as well. We want to know exactly when that method was called. And so let's build some code to store that. So we'll stop the server. and then we'll click on the search icon. We will go to the pattern model. And then we'll find the relevant line. So we can, I believe we could click on here and then, oh, there's no find in there. Command F will bring up find, but I don't know how to bring that up from the GUI. I'm not sure there is a way. Probably just find. No, it's not in there either. Anyway, Command F will do it for you. And here is the method. Now, before we carry on, let's talk a bit about what this method actually does. This is a method on pattern.rb. Pattern.rb is a model in our Rails app, and it stores and saves all the detail of the cross-stitch pattern in the database. Okay. This particular method adds a border to the preview. So the preview is generated, and that's the little bit in the middle of the, I can't show it to you right now, but it's it's the actual cross stitch in the middle of the, we call it the aider. It's like the little fabric that you cross stitch into. And so we want to add a border, like a 20 stitch border, just a blank border around every cross stitch. And that's what this method does. And so you can see it's almost impossible to read, especially if you didn't write this. So I left it messy deliberately so that this is kind of stuff I see in code bases all the time, and it's deliberately messy so nobody can understand it, and it's a slightly more realistic example than many other people talk about. So this is a line on which it is throwing an exception, erroring out. And we've got all of this code here. It could be on any one of these lines. But even more importantly, there could be something before this that is passing in corrupt data to this block. So not only does the stack trace not give us which of these lines is the problem, the stack trace also can't give us what any of these variables are. It can't tell us what has happened before this code was executed. And essentially, I think stack traces are, they're useful in very, very basic errors. I'm not saying they're completely useless. Of course, they can be useful to a degree, but they're massively overvalued. And people think that this is enough to run an app in 2025. It's kind of a bit bonkers. We've got all of these distributed systems, incredible complexity. And this thing here is our primary debugging tool. Give me a break. Like, it's okay, but it's not going to tell us much, especially when the system is relatively complicated. So that's my blah, blah, blah on that. The point is, this is the method we want to know that has been triggered. We want to create an event that says this method is being called, because everything in observability, really, at the root cause of it, is events. Okay, so close that. We're going to add, with all of that in mind, we're going to add some logging to this method, which is going to give us our event, and we're going to push a whole load of rich data into this log. One thing I don't think is talked about enough is that a log is just an event. That's what a log is. It is a record that something happened at this point in time. Okay. So let's create this. Let's write this code. I'm just going to copy and paste this in to the beginning of add border to preview. Okay. We're going to add all of this to the end of the method as well, because this opens up a block. Everything within semantic logger.tagged, everything within that block will be tagged with those attributes in the logs. So because it's a block, we need to close the block. This end here is how we're going to close the block. We also want to rescue, and I'll describe why in a second. We'll just indent all of this manually because we're gluttons for punishment. There really should be just an auto format somewhere, but I can't be bothered to find it right now. So I'll just put a new line there as well. We have all of this code that creates previews and so on. And at the very end, if it errors out, it's going to issue an error to the logs with the message and an event name, and then re-raise the error so that the app's behavior will still, it won't be changed, but we're just going to log the error before it exits. And then if it gets down here, we've succeeded. And so we can say logger.info board added to preview. Now, I should say this code is pretty hacky. I wouldn't say that this is production ready code by any stretch of the imagination, but this is a tutorial, it's an example. There are much cleaner ways of doing it, and this is the way I've done it. I tend not to use very clean code in workshop examples because people can't read it and easily understand it. You have to skip through all these abstractions, and our objective here is not to make production quality software. It's to demonstrate the principles to you in a way that you can just read it and say, oh, I see what's going on here. Okay, so we do need to make sure if you're doing it for yourself, make sure all the do ends match up. This end matches up to this end, so on and so forth. You know the drill in Ruby. It's very easy to miss that off. Then you're going to have a syntax error. Nothing really will tell you. So we're going to restart the server now with this new logging, and we'll see what we can see. We're going to restart the server. We're going to hit it again with bin hammer. Hammer the server again. Bin hammer. Once again, this will take a while to come through. And what we should see after we've run the query is a whole set of new errors. And we'll see these two different kinds of errors. We'll almost see double errors now, because one of them is the error that it was always showing before, which was the error that it was throwing. And then the other one is a log statement from us here with the event name added into it. It's kind of double logging the errors now. But that's what we want, because we want the same event name for whenever it's a success or a failure, which means we're going to be able to query this event name and get whatever the result of the operation was, whether it was an error or not. Okay, let's see if we have any data in Dynatrace to play with. Still not. We need to wait a little bit longer. Are there any questions from anyone? Anyone who's watching this? I'm just going to check on LinkedIn, see if I've got any messages. I do. Wow. All of the links I've sent out don't work. Thanks, LinkedIn. That's absolutely awesome. No wonder nobody is on the call. I'm absolutely gobsmacked. How can you? That's exactly the same link. Okay, let's try and share with, just bear with me, folks. Seems like nobody can get to this stream. This is really not good. Okay. View on LinkedIn. Copy link address. We're learning quite a lot from this first stream, in any case. This is a bit of a disaster, isn't it, really? I wonder if there's a way of me sharing this. Let's carry on, because why not? Okay, so this is what we should be seeing. Is the latest errors here coming through. You can see it's kind of doubling them up. So if we click on this error that we added the one that says error adding border to preview. If you look here, error adding border to preview. Going to look into this log here. Yeah, click on this specific error, and then we'll see the extra data that we need in that, hopefully. So if we scroll down, service name, that is what we added up here. Sorry, it's what we added in the formatter, isn't it, actually? The argument size, the size argument, the pattern ID, the width, the height, the function name. This is looking a lot more like something we could actually use to query on and do a bit of investigation. So we've gathered the height, the width, the error, and the event name, which are the three things that we needed. So finally, it's almost like we can actually ask the question we wanted to ask in the first place. So we're going to ask the question by showing these attributes as columns. So in this select statement here, select is just a list of attributes, as we all know. And so we're going to add those attributes into this table over here. So we can cancel this. Should be able to add columns. Okay. So we need to filter. I don't know why the columns hidden thing is not showing up. But anyway, we need to filter for this event name. So this is going to be the where first. We're going to do the where, and then we're going to select the attributes. My apologies. So we click into here. We go down to the event name here. We want all events with that name. So we filter by this. Run the query. This will filter out all the generic errors, just leaving our specific ones, which is great. And then we need to select the different attributes. So we need to show different columns. Now, it would normally say show different columns. And it's not saying that, and I'm not quite sure why. That button has just disappeared. Well, that's fun, isn't it? So if we click on here, we can add the columns in a different way. We need error. So we're going to go down here to error somewhere. It should just be true or false. There we go. I'm going to click add column. I have absolutely no idea why that button isn't coming up. That's very weird. And then pattern height and pattern width. Add column, add column. And this way we can see, if we close this, you'll see here that all the attributes that we care about. So far, so good. And we want to show all the logs. So right now we're just filtering out all the errors, but we want to see whether it's an error, yes or no, and the width and height. So what we can do is remove this error. So click cancel here, click run query, and there we go. So here are all the successes, and here are the errors. Cool. We're going to sort by errors so that we can see all the errors visually together. There are all the errors together, and here are all the successes. So what's the pattern? Is there any pattern that you can see here? We'll sort it by these things and these two attributes as well. So if we look down here, are there any errors that I can see that are obvious here? Well, for most of the errors, the width is more than the height. Width is more than the height. Hello, Renato.
Hey.
Just going through about halfway through. So welcome to the stream.
Thank you.
We're just looking at the pattern between errors and pattern widths and pattern heights.
Okay, interesting.
So you can see here, these three at the top have a width that is greater than the height. These ones down here have a height that is greater than the width. Any ones where the height and width are equal, they succeed. So it looks like it's only these three with the width greater than the height that are erroring out. So at this point, we might say to ourselves, so hang on, if the width is greater than the height, is that landscape? I mean, there's a definition for that, right? It's a landscape orientation.
Yeah.
So there is a bit of a kind of temptation to say, well, maybe we're just getting distracted here. Like, this is not the original hypothesis we had. The original hypothesis was it's something to do with size. But this seems quite interesting. It seems quite appealing. So we're going to go with it. And it's difficult to know whether this is a distraction or not until you've gone around this cycle many times. So in the flow of exploring things, we'll always learn new things. Old hypotheses may become less important, and we just need to be curious about what's going on here. In this case, we're going to chase down orientation. Do you have any questions, Renato?
No, I think that makes sense.
Cool. So we've got ourselves a new hypothesis now. Specific orientation causes the errors, and then the bottom line is we want to ask, do all errors happen with a specific orientation? And so in order to answer that for definite, we need to do a group by. pardon me, we could look at these, pardon me, we could look at these heights and widths and kind of take a bit of a guess at it. But in this case, because we've got a small amount of data, we could probably guess correctly. But if you're in a production system where you've got hundreds and hundreds of logs,
yeah, exactly,
you're not going to be able to see that just visually. So we're going to use group by. A group by is one of the most powerful SQL clauses that I know about, at least. But it turns out in observability, it's even more powerful. And it's kind of unsung. People don't really talk about it that much, and they certainly don't think of it as grouping by very often. And yet this is exactly what we're going to do, and you're going to see the power of it right now. And it's going to be able to group our logs into specific buckets, and then we'll be able to see very, very clearly, is there a problem with orientation or not? And so we're going to filter by the same events, that method called. We're not going to filter by any other attributes, and we're going to group by orientation error. And we're going to show the same attributes, broadly speaking, but we're going to group by these two things. So a group by is going to say for every unique combination of error, and remember error is just true or false, and orientation, which can be landscape, square, portrait, we're going to create a unique combination of each of those things. And we'll only show you the combinations of them. We won't show you if there's like 100,000 logs and there's only 4 combinations. We'll just show those 4 combinations or 6 or whatever. So we're actually missing the orientation of any pattern as the data. So this is the bit of data we're missing. We've got everything else in here. We've got the width, height, and the error. What we're missing is orientation. So we're going to add that. So just to recap, on me, we've gone back to the question phase. We've created a new hypothesis. We've defined the data we need to answer that new hypothesis. And now we're building the extra data that's missing. And it turns out build is a little bit of a fancy word for copy and paste one line of code. So we're going to go into here and add that one line. Orientation is a method on pattern. So if we call orientation, we're going to get a symbol with landscape, square, portrait. Pardon me, I should say that when Semantic Logger does its thing, it'll convert a symbol into a string. So this will end up in the logs as a string because you can't have symbols in JSON. It's impossible. So yeah, this is just a little bit of blurb explaining that because this is tagged, it will be tagged in both an error and a success case.
Cool.
So it will happen on every single time this code is called. It will always have that attribute. We're going to stop the app. I'm going to restart it, and then we're going to hit it with hammer again, and we will wait a moment for it to come through into Dynatrace. And while we're doing that, we will greet Renato properly and ask him if he has any questions about this code, or sorry, Renato, you've just been parachuted into the middle of this with no real context.
So I was curious on the. So you were saying that we would have an entry with the group by. We would have an entry for each of the combinations of error and orientation. So it kind of works like a truth table of the not the possible outcomes, but the real outcomes.
Correct. That's a good way of looking at it, actually.
Okay. So after this is done, we can just look at that and exactly. So you can even like. I see this being applied in basically every time you pull up a truth table and which logs can answer somewhat, you can see like, okay, I wish I could get this on actually my observability tool, and you can do it with a group by basically.
Yeah, totally. That's a really interesting point I haven't considered, because if you think about all the different ways in which software goes wrong, It's usually some edge case of logic somewhere, and then that propagates, and maybe there's another edge case that makes it even worse that somebody hasn't thought about. And a way of figuring out what those edge cases are truth tables. So if you can create a truth table in your observability tool with all the combinations of the various different factors that cause errors, you could then feed that back into your test suite and say, when this thing is set up and the invoice is in pending state and the customer is in the US, whatever, it will give you all the combinations to then backfill into your tests, replicate the error, you can fix the error, and then push that to production. You know it's going to work.
Yeah, exactly. Well, this is taking some time. Like, I know from like previous posts and all of that, you talk about the steps to observability, and it looked like we were like in the middle of one of the loops of it.
Yeah.
Did you do many loops before we reached this point, basically?
Yeah. So I'll just zoom back here, and you'll see that.
Okay, that was cycle 1. Okay, so this
We
is what,
are-
cycle 2, cycle 3?
I believe we're on cycle 3. Yeah.
Okay. I find that like it forces you to actually iterate on the thing, because you create a small event, and then you make it wider as you need more data to it.
Yeah, it's a good point. And it's important to remind everybody that you don't have to go back to the beginning of the cycle. This is why the diagram, wherever it is, here has all of these little arrows. So at the use stage, the use is almost always the stage where you figure out something needs to be improved. The moment you actually try and answer the question, either you get an answer and you want to re-ask a different question, or more likely you think, oh, we've missed this data, or we need this to do it in this slightly different way, or there's more data to collect, or there's less, or we need to reframe the question slightly. Maybe we need to actually, we thought we needed 3 attributes, maybe we need a 4th.
Yeah.
So yeah, you can go to any one of these stages. But this this entire cycle is really a slightly more complex version of test-driven development. I mean,
Yeah, I guess I get that. I get that.
One of the XP principles is feedback, so it's nothing new really. Every great software technique, there's some aspect of feedback to it.
Yeah, but it's applied to a very specific domain, so
yeah.
I do see it as helping.
Cool. So we've run our bin hammer, and so with any luck now, that chat has given Dynatrace a chance to do its thing. And we can see, indeed, we've got some errors here. So what's the next step? We've added this code, and we're now going to use it. And we're going to group the error by app.pattern.orientation. And just as a side note, in case you're wondering why I didn't just use the word orientation here, namespacing when it comes to, pardon me, when it comes to naming attributes, namespacing is incredibly powerful. And without namespacing, it turns out you end up in a real mess. If you just have orientation, what is that the orientation of? Is it the orientation of a mobile device? Is it the orientation of the laptop screen? Is the orientation of an invoice or a PDF? Or it could mean any number of things. So I tend to do, this is a very basic namespace. In general, I would name these things under like bounded context, if you're familiar with DDD, and then this is the name of the domain object, and then this is the attribute. So you can see that an orientation belongs to a pattern, and you can have as many segments as makes sense for your use case, and then you can start to develop a kind of language to talk about your app with all your colleagues that standardize, you document someone, and everybody knows what each attribute is for.
Yeah, that makes lots of sense. Even today, I was like using Datadog. I was searching for the attribute was called like it had namespace and then reason. And if it didn't have that namespace, like what does that mean? So it's like the reason for something to be skipped. So,
right. Yeah, makes sense. Now, Slightly annoyingly, in Dynatrace, there is no group by button in the UI. So we need to start using Dynatrace's custom query language called DDL, which is a variant of SQL, as you might imagine, to do the group by. So to do that, we click here and click Edit DDL Query, and it enters a different mode. And you can skip between the GUI version and the DDL query. We're going to change the DDL query to be this. And I'll explain it in a minute, but for now, I'll just copy and paste it in. And we'll click Run. Now,
There's our truth table.
there's our truth table, exactly. Now, there is one thing here which is a bit annoying, which is we have null orientation. I wonder if do you know why there's a null there? Can you guess?
No, I can't. Because like square is already taken, so that's confusing to me.
Yeah, it's very confusing. And so we're going to go back to the previous filter. And maybe the graph will give you a hint.
Is this before we added okay, so these are the older ones. So you're saying if we actually, I was trying to draw on the screen, if we just go to the most recent events, we should have no nulls, basically.
Correct. Yeah.
Okay.
There are ways, very sophisticated ways of getting around this. The non-sophisticated, fairly crummy way is just to drag over the area that you want. This hard codes this timeline, which can be very inconvenient depending on what you're trying to do. In our case, it doesn't matter because all the logs are already there.
We could also, like in the query, probably exclude those results.
We also could. That can be a little bit dangerous because you're then filtering by another attribute. And then if you kind of choose the wrong filtering attribute, or maybe there are some nulls that you would prefer to see, you're now getting
this seems safer.
Getting other data. What the best way of doing this, that I've seen at least, is every release is tagged with UUID, which is usually, actually it's not UUID, it's usually the SHA of the version of the code that was deployed.
Okay, cool. Then that way you can filter, okay, this is the version of the code after the change. So exactly you can just, you can have the time frame be as large as you want anyways. Okay.
Exactly.
Makes sense.
This is another thing, I'm glad this came up, because this is another thing I see a lot of people get confused with, is this time selector. People are constantly selecting the wrong time. And if you make queries such that the time becomes almost irrelevant, you should really be able to set this time period to maybe a week or a few days or a few months or whatever, and the query that you have should still work. There are exceptions to that, of course, but if you make your queries robust, and so that basically no matter what date range you select, it's going to give you valid data, that's really powerful. It means you need to faff about less, and there's less to kind of reason about. So we're going to paste this DDL query in. I promise I will explain it in a second. And there you go, all the nulls have gone because it's on the most recent one.
Nice.
And so as this...
Wait, could you go at the result? Like, we only have a much clearer picture. We only have errors on landscape.
Yeah. And what's really even cooler is it gives us the count of how many there are.
Yeah.
In other tools, and maybe even in...
Oh, that's interesting. So like if we were in a production, in a real production environment, and imagining it was flaky, it didn't error out all the time, we could still see a distribution and have an idea of like, this mostly fails on landscape or whatever. Okay.
Exactly, yeah. You could have percentage of time it's failed. Maybe the landscape is 93%. Maybe it's not all the time. Yeah. And there should be a way of graphing this with Dynatrace. I'm not yet that familiar with Dynatrace. There'll be notebooks that you can put this into and make a little graph of this, but I don't see any way of doing it immediately from this screen. So I did promise I was going to explain this DDL query.
Yeah.
So I will do my best now. So fetch logs is essentially saying select everything from the logs, because you've got logs and traces and metrics. This tells Dynatrace that it's all log data. This is a simple filter. It's just saying the event name property should match this value.
Yeah, that we added before, yeah.
And then this is the bit where it gets a little bit hairy and a bit difficult to reason about. We have the word summarize, and summarize is, there is no group by clause in DDL, I realized. Okay. So summarize takes an aggregation function, and then it takes a grouping function.
Okay.
So this would be very similar to, in the SQL up here, count star. So
okay.
Group by these two things, and then this is the aggregation I want to show when they are grouped. And
okay.
The super cool thing is here, this aggregation function can be P95 or average or sum or
nice.
min, you know, so there's loads of flexible things to do this. In this case, the count doesn't really matter that much, but for more complex examples, this comes into play. It can be incredibly useful.
Cool.
So, yeah, DDL takes a little bit of getting used to, and I wish there was a sequel to DDL query converter somewhere. Maybe there is somewhere online. So the point of all of this, of course, is if we have 3 orientations and each one is failing and succeeding, we'd actually have 6 combinations here, and we have 3, and that's immediately telling us only landscape fails.
Yeah.
And look at how compact that is. This is why group by is absolutely incredible.
Yeah.
It reduces the amount of work that you have to do by maybe about 1,000, maybe 10,000. No more copying and pasting into Excel for us. Anyway, so we've got the answer to our question. Do we have enough data to fix the issue now? So I've always said at the beginning of this stream, I see a lot of teams looking at the code, going back to stack trace, and you can see their faces just like shrinking further and further on their palms, and like kind of going to sleep and getting really desperate. And going, could it be this line? I'm not sure. Could it be this line? Now that we've actually gathered some data about what's going on, and we know it's something to do with orientation, now we kind of know where to look in the code. We've got a thread to pull on. Yeah. So in Replit, one nice feature is you can double click on any word and it will highlight all the other words. You can see here, immediately it's showing up this line. So let me just shrink this down so we can see this line. And I will try. Ugh, that's not great, is it? We'll just keep it the same size. You can see it's doing a dig, converting orientation to a symbol. And if you're not familiar with Ruby, this is a digs through several layers of a hash. So this will be a hash, a nested hash, basically. It accesses the orientation, and then within that orientation, it accesses a key of size. So that's interesting. Let's look at what's in that constant. So I'm going to paste that into find. Here it is. Maybe for those of you who are rather switched on, you may be able to see portrait and square. There is no landscape.
So dig does not raise an error. Just returns what, a nil?
Good point. Yes, thank you. Dig returns the best value of them all, which, as we all know, is nil. Isn't that a wonderful thing? The root of every developer's pain.
So that's I don't even remember the original error, but it was something completely obtuse and not specific to this line.
Exactly. So this is the classic case of you have code A that calls code B calls C, calls D, calls E. It blows up at E. Everybody's looking in the area around E, and nobody realizes that actually B introduced a nil way upstream.
Exactly.
In this case, it's even in the same file, which is quite nice. But in many cases, it can be in an upstream service. It can be like in the piece of code that scheduled a background job. And this is why it's so important to see the events flowing through your system, because you can then reverse engineer and figure out where was the nil actually introduced.
Exactly.
And that's kind of what we've done here. And so let's just recap here. It's accessing this constant. It's calling dig on the hash. It's going to orientation. It's trying to access the orientation key. Orientation is not there because orientation is landscape at this point. It tries to access size, but given that it's not being able to access the landscape key, it just says, oh, I'll give up. I'm just returning nothing. This means width from border, width with border and height with border are both nil. In Ruby, if you pass in a nil and string interpolate it like this, you will just get a string that says X, because converting a nil to string is just an empty string. This is the root cause of the problem. And this is also, by the way, why I like fetch, because fetch will blow up if the key is not there.
You mean Ruby fetch?
Correct, yeah. It's a method on a hash.
Yeah.
So you can you'd be able to do...
Yeah, so if we had a fetch orientation, then fetch size, yeah, it would blow up. We would know immediately at the orientation. But we don't live in a perfect world. Our code bases are complex.
Correct.
Observability is there to help.
Correct. And the other thing that not many people talk about with fetch is even the fetch error is terrible. It doesn't tell you what key it was trying to get, which is, it was only relatively recently I figured out how this was such a problem. If you did this, it was basically say, can't find key, no such key, but it doesn't even tell you the key. It maybe tells you the key, but it certainly doesn't tell you the original hash that we're trying to access it on. So even fetch is extremely limited in the data it can give.
I see.
So this is, from here, we are very, very close to fixing this and finishing. So let's go into the shell. We used to have a show here in the UK called Blue Peter, where they would say, you can do all of these things. Step 1, put the sellotape on. Step 2, tie shoelaces around, whatever. And then they would say, and here's one I made earlier. So this is in typical Blue Peter fashion. Here's one I made earlier. I've already given...
like the cooking shows where they have like the thing just out of the oven after mixing the ingredients. Yeah.
This takes a long time to cook. Instead of doing that, I have one here that I prepared. So this is...
So you're adding the missing landscape.
Yeah, exactly. And I'm doing this because you have to have the missing landscape in a few different places for it all to work.
Okay, cool.
Okay. So this is just showing the fix, just to verify we're not going to add something crazy into our code base. I'm going to run these 3 lines. Oh, it ran all of them. That's a bit annoying. Git stash, git cherry pick, and then git stash pop. So let's have a look at preview with border dimensions now.
Okay, there
it is. It's got landscape in there. And if we go to a shell, do git diff, git diff staged. That's strange. I don't know why it's... Oh, I know why. It doesn't matter. There is no git repo with this. So yeah, anyway, we've got those. We've got those git diffs being added into there, and it's fixed the issue. So now, with any luck,
we could submit the original file and it shouldn't hang, right?
Correct, hopefully, yeah. It's a bit weird that it said there was no git diffs. That makes me believe something's slightly gone wrong somewhere, but we'll soon see. So we choose the puffins, which is the pattern that didn't work. And cross our fingers.
Just because this is the one that went into landscape.
Yeah, and
it was in the landscape layout, yeah.
And it crashed the server.
Oh, there it is.
And this time it works.
Cool.
And these are two little puffins that my partner cross-stitched when we went to a little place called Rathlin Island, where these puffins, it's off the north coast of Ireland. So there you go. So it's all working now. And that is the end of the live stream. I have a cheat sheet for you here that I will put in the link on the YouTube video and put in the comments of this event. Just one thing to note about the cheat sheet is if you scroll down, it's essentially kind of giving you a step-by-step guide on what we've gone through in this session, but it just requires a little bit of explanation. So it's talking about what we talked about here, list hypotheses, sort them out, form a specific question, and then we go to the second step. After we've decided our data, you have two options. You might say, oh, we already have that data. Let's say you don't already have the data in the tool. It then gives you a recommendation of what step to go to. And you click on that, it goes to that step. You can ask these questions if you want. Maybe that's too much in depth for you. Go to step 4, use. And then once you've used it, it will walk you through once again. Okay, your question is answered, but the hypothesis is still unsolved. And then it'll say, well, you need to go back to step 1 and so on and so forth. So you can kind of use it to reinforce this process. And
okay, so what we did here, next time on my job, when I have a similar issue, or like it seems like observability would be the answer, or at least for me to have a pull to a string to pull, I could just go through this. It's almost like a flow chart to reproduce this process we just saw, but on something specific to my...
Exactly. And I do have plans to create a little flow chart, but the problem with the flow chart is you kind of can't put all of this detail on a flow chart.
No, of course. This needs to be flexible enough, otherwise it can't be used. Interesting. I'll be giving this a use for sure.
Cool. All right. Any more questions before
Where can we find you?
Where can we find me? You can find me on LinkedIn. That's where I normally post about, but there's also my link tree, which I will put in the chat here. 1 second. This is my link tree. This has all my talks, all my content. And you can see here, you can sign up for my newsletter if you like. There's a few calls that I open myself up to for free if you'd like to chat more. Here is the cheat sheet you just saw, and then there's videos and articles. And I went on a little podcast here, and then there's a book I wrote a couple of years ago now.
Cool. Thank you very much.
Thank you for showing up, and I'll see everybody on the next one. Thanks for watching.
See ya.
Bye, everybody.
Bye.